Okay, so because this is about series again, we need to have a look back through all of the formulas and things that we have learnt from the other topic that we did at the end of term 4 on series. These are the formulas that are on your formula sheet. You'll note there's the compound interest formula there that we haven't really used a lot of, but it will be useful towards the middle and end of this topic. We will be using that. We have our term and sum of an arithmetic progression. So you could make a note on here if you want to that this is for the APs. And these ones down here are for the GPs. The limiting sum is the bottom one that only happens for a geometric progression. Arithmetic sequence is a little summary to go back over what we should hopefully remember. The term of an arithmetic series is found by adding a common difference to the previous term. So D is the common difference, N is the position of the term in the sequence. The nth term of an arithmetic series can be found using A and D, and is using this formula here. 3 numbers, A, X, and B, are part of an arithmetic series if you subtract that third term minus second term, and first term, second term minus first term. If you subtract those things, they should be equal to each other. Or you could average the first one and the third one, so A plus B over 2, and that should tell you the X, the second term in the middle. The sum of an arithmetic series can be found with either of these two formulas here. The first one can only be used if you're given L, which is the last term, or if you don't know that, you'd be using the second one. On to the geometric sequences. A geometric sequence is formed by multiplying by a constant ratio or a common ratio, which we call R. It can be calculated. R can be calculated by dividing two consecutive terms. So it says there T of n over T of n minus 1. Any term of a geometric sequence with the first term A and the common ratio R can be found using the formula. Now, the one that I'm highlighting here, T of n equals A R to the n minus 1, is the one that's on our formula sheet. But there is also this one here. If you know some of the terms here, all you need to do is multiply by the common ratio to find the next term, which is what that one means. 3 numbers, A, X, and B, are part of a geometric sequence. So that means you're going to divide. We're going to do B over X is equal to X over A, because both of those things would be equal to the common ratio. If I rearranged that, if I did some cross multiplying, X times X makes X squared, and cross multiply the other way, A times B. So you could also have X squared equals A times B. The sum of the terms of a geometric series, there is 2 formulas because it depends on R. If R is, or the absolute value of R is greater than 1, we use the first formula. If it's less than 1, we use the second formula. And the way I remember that is I don't want whatever's on my denominator or in my bracket here to be negative. So if R is less than 1, I'm going to want to subtract off the R from the 1, keeping it positive. But if it's greater than 1, I want to do my ratio minus the 1, keeping that value positive. To find the limiting sum, or the sum to infinity, we have this formula, and remember that R, the absolute value of R, must be less than 1. That means the terms in your series are getting smaller, and they're the only types of series that have a limiting sum. If the terms are getting bigger, that means every time you add something else on, it's getting much, much bigger every time, so there's no limiting sum. Okay? All right, questions. Example number 1. Find x if 6, x, 54 is an AP or an arithmetic progression. Arithmetic means that I should be able to subtract 2 take away 1 and 3 take away 2, and they should be equal to each other because that would be the common difference each time, right? So let's write that down. X take away 6 would be one way of finding the common difference, and 54 take away x would be another way. So if I solve that equation for x, then that's what I need. So let's move the minus x across the other side. 2x. Move the negative 6 across to the right. So adding 6, we get 60. Dividing by 2, we get x is equal to 30. Okay, same numbers, 6x and 54, but this time it is a GP, which means we want to find a common ratio. So using the first and the second term, x over 6 would be the common ratio. And the second and third term, we would do 54 over x. Both of those would be the ratio, so we make them equal to each other, and now we can solve for x. I'm going to cross multiply. So x times x is x squared. 54 times 6 is 324. To solve it, I need to square root. The square root of 324 is 18. Is that the answer? Oh, you knew when I said that, I was playing a little trick there. Yes, when I square root, it needs to be a plus or a minus because it works for this middle number either way. If I times by, that doesn't mean, that's not my ratio, that's my middle term, right? So my ratio could be a plus 3 or a minus 3. So if I times by a negative 3, I get negative 18. Times by a negative 3 again, it goes back to a positive 54. So it does work for the negative option as well. Okay, moving on. Question 3. Fred earned $25,000 in his first year as a pizza delivery driver, and his salary then increased by $4,000. He worked at the company for 14 years. What is his annual salary in the final year? Okay, so the first term, this is a series, the first term in my series is $25,000 because that was what he got paid in the first year. Each year his pay is increasing by $4,000. So the second year he's going to get paid $29,000. In the third year he's going to get paid $33,000. And then just put some dots there. Going to keep adding on $4,000, and that's what his pay is going to be increasing to each year. So we've seen that the series is building there, and if I want his salary in the final year, I don't want to do it 14 times, I'm going to use one of my formulas. A is 25,000. D is a positive 4,000, and N is equal to the 14th term that I want to find. The formula for the term of an arithmetic series is T of n equals A plus n minus 1 in brackets times the D. So we sub these things over here on the left, we sub them in. It will be term 14 will be equal to 25,000 plus 14 take away 1 in brackets times by 4,000. You guys got an answer? What did you get? That's right. Well done. Okay, question B. I'm going to change this here to be 14 years because then it kind of matches the one above. What were his total earnings over the 14 years? I could do it with 12, but I want to be able to use the other formula. Did you do it? That's okay. You can leave that. You're still right. Okay, you shouldn't be going ahead. No, you can. What are his total earnings? So that means I want to sum up all of his pay over those 14 years. So because I have chosen to change that to 14, I could use the formula S of n equals n over 2 bracket A plus L. because the last term in that series would be the term 14, which I found here in part A. Okay, so n is 14 over 2. This is sum of 14. Bracket 25,000 plus 77,000. And then we get an answer of $714,000. You can still use the other sum formula if you want to. It still works. Give you the same answer. Question 4. Gosford Council is very happy. It had 2,870 complaints in 2006, but only 2,170 in 2016. So that's why they're happy, because it's getting slightly better. The number of complaints decreased by the same amount each year. What was the total number of complaints during these years? Okay, so we started with 2,870 complaints. Then we have some terms in the middle that we don't know yet. And then we have a final term, number of complaints, was 2,170. What was wrong? Oh, okay. So, the total that I have there, if I list off the things that I have, I know the first term. I know the number of terms that would be in that complete series. What would it be? It's 11. Because it counts 2006 and 2016, so it's 11. And we know that the last term is the 2170. Okay, so we actually have enough information there to use our sum formula given the first and the last term. Okay, we don't know D. That's okay, we don't need D for that formula. So let's put it in. There is 11 terms, and we have 2870 plus 2170. And that means there was 27,720 complaints in 11 years. Yikes. Okay, question B. By how much did the number of complaints decrease each year? That's asking us to find D. All right, what do I know? I know that the 11th term is 2170. Because the term formula is T of n equals A plus n minus 1 D. I know the 11th term, I know A, I know n, and that leaves the one thing I'm trying to find, D. So I can use that to solve for D. So let's sub in. My term was 2170. My first term was 2870. There was 11 terms there, so 11 take away 1, and that's times by my D. So, subtract the 2,870 across to the other side, and you get negative 700. 11 take away 1 is 10D. So, if you divide by the 10, you get negative 70. Negative, because the terms are going down, they are decreasing, so that means there is 70 less complaints every year. You could write that out to explain it. Therefore, the number of complaints decreased by 70 each year. If the trend continued, in what year would there be no complaints at all? So no complaints, that means I want my term, whatever position it's in, to be equal to 0. And I'm trying to find n, because I want to know how many years does it take to get to that 0 complaints. Which formula am I going to use? The term formula. So I want the term to be equal to 0. So T of n equals A plus n minus 1D. My term is going to be 0. My first term is 2870. Don't know the n. So n minus 1 times by negative 70. Thinking back on your test for this topic, I remember as soon as a minus sign gets missed, it messes up the whole question. So don't miss minus signs. All right, well, let's expand out and solve. 2870 minus 70n plus 70. Okay, moving the 70n across to make it positive. And at the same time, 2,870 plus another 70 makes 2,940. 3,940. Okay, and then divide the 70. What do you get? N equals 42. Okay. N equals 42. Have I completely answered the question? In what year? Can I say in year 42? Maybe think back to the question. We started in the year 2006, went 2016. So could you say what year, 2000 something, that there is finally going to be no complaints? Think about it, including that first one. So what am I going to do? So therefore, think about it while I write this down. There would be in the year. Okay, we started with 2006. Am I going to add on 42? Yeah, I've got to subtract off the 1. Okay, because the first year, 2006, has already been counted. So 2047 is the answer. You like that? Yeah. All right, question 5. Sales from the warm and fuzzy calculators in the mountain town of Matsville are declining by 6% every year. In 2016, there were 50,000 calculators were sold. Okay. That means our series is starting with 50,000 calculators. It is decreasing by 6% each year. What's my next number? You're going to times 50,000 by what? No, that will find what 6% is, but I still want the other. What percentage do I want? 94%. So times the 50,000, go times by 0.94 because that has decreased it by 6%. Yes? So it will be, yes, 47,000. Okay, practice, times it by another 0.94, and your next one should be 44180. So there is my sales of calculators that are declining by 6% every year. So how many calculators are going to be sold in 2025? All right, I know A. I know R. R is 0.94 that I was multiplying by. What is N? Yes? Were you sure about that when you said it? You were? Oh, good. It is 10. So it's 2016 to 2025, but it's because it includes the 2016. All right, so if you do 25 minus 16, you only get 9, but you have to add on the extra 1 because it's including 2016 and the 2025. Okay, so yeah, you can count up on your fingers, 10 years. Okay, all right, so we are trying to find the term What type of series is this? Geometric. So this is going to be AR to the n minus 1. Subbing in term 10 is going to be 50,000 times 0.94 to the power of 9. I'm just taking the 1 straight off it. Okay? And type it in. You'll get a decimal. So I'll type it in. Should I type it in? We get 50,000 times 0.94 to the power of 9. Okay, how am I going to leave this answer? Always round down, you reckon? I just rounded to the nearest whole because it is an approximate thing. So you just can't have a decimal. You can't have a decimal because you can't sell a 0.9 of a calculator. I guess you could, if you explained, you'd say, I haven't quite sold that extra 1 calculator yet. Yeah, I could accept the round down. Yeah, right. That's to the nearest whole number. Question B. How many calculators will be sold in total between 2016 and 2025? So that is a sum. I want to sum this series. Because R is less than 1, we're going to use the A1 minus R to the N over 1 minus R. So that's a sum of 10 terms. A is 50,000. 1 minus 0.94 to the power of 10 for 10 terms over 1 minus 0.94. And we get 384,487 calculators. What would the total sales from 2016 onwards be eventually? Eventually. Limiting sum. So, limiting sum is A over 1 minus R. A is 50,000. 1 minus the 0.94 means that the total number of calculators that they would ever expect to sell is 833,333 based on that model. D. What proportion of those sales would occur in 2025? 2025 was the term that we worked out in part A, was it? Yes. Actually, but it wasn't the term though. What proportion of the sales that would occur by the end of 2025? What does that mean? That means the sum up to 2025, which means we're actually going to look at B, because B was the sum. Okay? If I just wanted just the year 2025, it would have been A, but it says how much has occurred by 2025. A lot is hidden in that little sentence. So it was the total amount up to 2025. Which means we're going to take the sum of our 10 terms. A proportion is a fraction over the total. And the total number of calculators we're ever going to sell was our limiting sum, our sum to infinity. Okay? So our sum of 10, looking back to B, was 384,487. We put it over the 833,333, and unfortunately it doesn't work very nicely. I did it as a decimal. So as a decimal that comes out as 0.4614, or maybe you'd like that as a percent, so that's 46.14%. So almost half of their sales are happening in that first 11 terms, and then it's going to taper off quite drastically for the rest. All right, so 14A.